Hello, everyone. This is Ajay Mittal, and I'm going to be talking about Java Part 1. And I'm assuming that you have installed the Java Development Kit on your machine, and we are going to examine the structure of Java programs, how they compile and run in this session. A little bit background. So the language was created by a person called James Gosling in 95 while he was working at Sun Microsystems. It's a general purpose object oriented language. There are different versions of it, all the way going up to 25 right now. And we are just going to work with JDK 8 because it has the most important features. Let's cover a little bit about how a program works on a CPU in a very simplistic fashion. So when we run a program, the operating system will load it into a block in the RAM. The CPU will grab an instruction from the RAM and execute it. It will grab the next instruction and execute it. What are these instructions that the CPU is executing? That depends on what kind of CPU we have. If I look at my computer CPU, it's an Intel CPU. That means the CPU is working with the x86 language. This is a language that the Intel company created. The CPU doesn't know how to run anything else. It doesn't know Java, C++, or any other language. It knows the x86 language. And exploring a little bit on the history of object-oriented languages, which Java is, we have the machine language instructions. Machine language instructions look like this. There are a bunch of zeros and one. Once each line is one instruction, it can take arguments, literal values. As you can imagine, it's very difficult to write and understand these instructions. So the next phase that came was assembly language. Assembly language, each instruction corresponds to a machine language instruction. And it's sort of the command written in zeros and ones. We have it written in a mnemonic form, such as move. It's this instruction means load the AL register with an immediate value of 1. You have to know how the CPU architect is, what are the registers in it. You need a little bit more knowledge of the CPU. It's better than machine language, but still very tedious to programming. Next, we had the procedural languages, and these were languages such as Fortran, Pascal, C, and a lot of programming was done in these languages. The domain problem gets written as function calls. One function calls another function call, and then we can have structures and data that the function calls pass to each other, or the data can exist globally. Now, the main problem that the programming is solving is how to deal with very large programs that are complex. Large programs means they can go into thousands of lines, sometimes even million lines. How do you maintain such programs so they are flexible and easier to modify and change and test and so on? So we come to the next stage, which is object-oriented languages. Now, note, these are not the only paradigms as far as languages are concerned. We have list-oriented languages such as Lisp. We have languages such as Prolog that dealt with artificial intelligence and stuff like that, right? We are just looking at a particular section of languages. The concept behind object-oriented language is that the domain problem in real life can be implemented as a class with properties and methods. So now, instead of one function calling another, we have a bunch of classes that are closely related to the problem at hand, and the classes interact with each other. So that's what the concept is behind object-oriented languages. And in this category, we have languages such as Java, C Sharp, and C++. Java syntax is based on the C++ language. I have two links here that you can download JDK 8 from for Windows and for Mac. I'm not going to go into the installation step. I'm assuming the user knows how to do that. The .java files are basically text files. We can use any editor to create and edit the text files. I'm basically using TextEdit because TextPad, I'm sorry, because it provides syntax coloring. Now, reason we are using JDK and TextEdit instead of using an IDE like IntelliJ or Eclipse or NetBeans is because we want to understand it from a little bit lower level. In the IDE, we don't really get a sense of that. And in my particular case over here, I'm going to be storing the Java files in a particular folder. This is where I'll be storing the files. There are two batch files that I'm going to use. Batch file is basically a text file that we can run under DOS. I know it's a little bit old technology, but it's useful for our case. I installed my JDK 1.8 in the C drive. So if I look at my C drive, I can see JDK 1.8. By the way, one advantage to this approach that we are doing with JDK, using the JDK form is we can experiment with different JDKs. You can see I've got JDK 11, 17, and 21 installed as well. And if you look at the bin folder, this has the executable Java C for compiling and Java for running that we want to use. So I've included it in my path over here. What is this path represent? So let's look at it by going to the DOS prompt. Let me open a new DOS prompt to show how the path works. Path is an environment variable. Environment variables are used by the operating system to customize the environment. They are used on Windows. They are also used on Unix and Mac. If I look at my current path variable value, which I can do by %path% with the echo command, I see this. It's a bunch of folders separated by semicolon. If you did this on the Mac using the terminal, you will also see a bunch of folders separated by the colon. Now, when I type in Notepad, what happens? Windows will look at each of these folders and try to check if there's an executable file called Notepad. And if it finds it, it will start it up. Notepad happens to reside in the Windows System 32 folder. So this is where it finds it. There we go. It started Notepad, right? If I clear out the path and I type in Notepad again, it's not going to find it because it doesn't know which folders to look in for the executables. So what we've done with our batch file, we've set the path. Let's go over here. Typo there. So by the way, this hash means comment, so these two are not used. So we've set the 1.8 bin path so that when I do Java C, it finds a command. And I've also put the path to my folder here with the source files. The reason I've done that is I'm going to use another file, which I'm calling run1.bat. And what this does is it basically helps me compile and run the Java programs. So instead of doing Java C, hello world.java, and then Java hello world, I can just say run one hello world, right? And this batch file will run each of these commands. It removes the old class file so that if there is some problem with the compilation, this Java command doesn't run. Let's look at the hello world.java over here. I have it over here. You can either copy and paste this, or you can download this file also, put it in your source folder. I go to my folder. Now I'm going to compile it. I can hit the tab key so that it will type in rest of the file name. So there seems to be a problem. So we get some compiler errors. Must have been modifying it. So let's go and look at the hello world.java and correct the error. Now it compiled without any problem. And now I can say Java. Well, if I look at the file that the Java C created, it created a dot class file. This is composed of something called bytecodes. Bytecodes are like machine language instructions, but they are virtual. They are something that the Java people made up. They don't correspond to any specific CPU like the Intel CPU or an operating system. They are agnostic of the hardware and the operating system. However, because they are not machine language instructions, I can't run them as they are. I need another program that understands bytecodes to run. That program is called the Java Virtual Machine. Over here, I invoke it by using the Java command. The Java executable itself resides in the JDK 1.8 bin folder. I say Java. Oops, need to do this without the dot class, and I can run it and execute the program. It's a very simple program. It prints hello world on the console. Now, using the run one batch file, I can just say hello W, and this hello world gets passed as an argument to the run one batch file. I hit enter. it erases the current class, does a Java C, and then runs it. So it's helps a little bit. We can still manually do Java C Java if we want to. Let me do something over here. I'm going to remove world from this and try to compile the program again. You can see that we get an error during compilation. Class hello is public, should be declared in a file named hello.java. What Java is saying is that you've got a public class, this hello, save it in a file called hello.java. The name of the public class should be the same as the file that I'm saving it in. What does this public mean? This means the access level. Where can I access the files from? Java uses a folder, subfolder kind strategy to define packages and so on. So, and this position over here, either I can make it public, which means this class can be accessed from anywhere, or I can remove it. This is also called the default or the package access. In this case, only files in this particular package, which is in this particular folder, will be able to access hello. Back to as to why Java requires that the name of the file be the same as hello world. Well, if I have a public class in some files and I'm looking at a Java program which might be composed of multiple files, right? We won't just have one file in our program. By looking at the Java files, I can sort of guess that it has a public class. If there was a public class inside this file named hello world, makes it a little bit easier to find public classes if I'm looking at a lot of files. So it's basically for organization purposes. Now, let's go back to this and see how multiple Java files can work together. Okay. So I've got a let's go back to the intro folder. I've got a file here called use my math. It is importing what is called a package. A package means a collection of files, right? This is how we can think of it as a namespace kind of thing, right? And what I'm saying is I'm expecting a class in this package, and that class is addition, which has a method that I'm invoking in this particular use my math. So I'm basically, my application consists of two files. One is this main file, which has a main method. So anytime I want to run a Java application, the class that I want to run should have a main method. This is the entry point for the Java application. This is how Java knows where to start executing your code from. Coming back to this package, right? So Java is expecting a folder called mymath. So if I open this folder, I've got a mymath folder. In this mymath folder, I've got a class called addition. Now, this class is a public class and it's in a package called mymath. This is important because Java expects this package name to be the same as the subfolder mymath over here. And this could be a hierarchy under the mymath. I could have a dot trig, and then this file should be in a folder called mymath, which should have a subfolder called mytrig. The looking for the mymath folder starts from this intro. So it's this mymath folder that's important. This is how Java programs are structured. Within this, I have a method called add two numbers. It's a simple method taking two integer arguments and returning their sum. Let's try to make this two programs work together. I first go to my math folder. I do a Java C on addition.java. That compiles and creates the addition.class. Then I go one level up and I compile the use my math. Where I need to do a C. So little typo there. Okay, it compiled it fine. At this point, if it couldn't find the addition, the mymath package or the addition file, it would have complained by now. So how did Java C work? Java C went to the use my math.java, came over here. Oh, there's a package that we're trying to import. We don't have something called a class path right now, and I'll get to that later. So it's going to look in the current folder of use my math, which is this intro folder. And in this folder, it's going to look for the my math folder. In that my math folder, it's going to find this addition class, and that's where it picks this class up for. Checks whether that class has an add two numbers method, and so on. Now I can type in Java. Just the use my math. This is the main class that it's going to run. And we can see it adds those two numbers, 2 and 5 and 7. Let's see what the class path concept is about. I'm going to take that use my math Java file and put it somewhere else. I'm putting it in a use my, my source folder on the C colon drive. Let me make sure that I erase everything else which is in that folder. I've got a jar file here and so on. Let's erase those. So I just have this file. This file is using my math package over here. Let's go to this folder. Try to compile the file. We can't compile it because it doesn't find the package mymath. This is the reason we get this error. We need to tell the use my math.java, hey, look, I do have a package, but it exists somewhere else. Where does it exist? It exists in this intro folder. That's where the my math package is. My main file is different from the file of the package with the folder structure where it is. To help us do that, we have the concept of a class path. There are two ways I can specify the class path. I can say -cp and put the class path like this. If there were multiple paths, I can separate them by semicolon. And just like we saw with the path environment variable, the class path works in a similar manner. We look at each folder. So let me try to run this first, see if it succeeds. It does. It will look in this folder for another subfolder called mymath. It will find it. It will check whether it has the addition class, and it will find the addition class, and then it proceeds to compile it. We can use the same strategy in running the program. The -c is short for minus class path. We can also do minus class path and type the whole word class path instead of CP. And then, as we know, we only need to give the class path instead of .java. Right, that also runs it. If we don't want to specify the class path on the command line, we can use a variable, environment variable that Java understands. So I'm going to do set class path, and this is my class path. One thing to note is if I don't have the class path variable set here or in the -cp, then Java will look in the current folder. But if I have class path set, it will look in the class path, the value, the folder specified here, but it won't look in the current folder. So good idea, if we have something in the current folder, is to specify dot, which means current folder, and then semicolon, and then this. So now I've set the class path to this. If we have spaces in our names, we can put this whole line in double quotes like this. Now that I've set my class path using the arrow key, and I'm going to get rid of this one and compile it, and it finds it. What is it doing? It's checking, do you have a class path set? Yes. Then it's going to each folder. It will go to the current folder. Hey, there's no mymath subfolder. Then it will go to this intro folder. Do you have, is there a mymath subfolder there? Yes, there is. So then it finds it and looks for the addition to it. So if we have files that are in different folders from the folder where our main file is, this is how we can tell the Java compiler and the Java command to find those other classes. Not everything has to be in the same folder. Now, if you have many classes, 10, 20 classes, and they're distributed in folders, subfolders, how do I distribute those files to someone? So Java has a scheme for that, and we'll use that scheme now. So let's go back to our intro folder. And what we are going to do is we are going to bundle the addition.java into something called jar file. Let me get the instructions from the website. So this is the jar command. -cvf means create a jar as specify the name here. And this is the subfolder. And inside the subfolder, these are the files that I want to put in my jar file. I run the command over here, and it creates a file called mymath.jar. We can see it got created just now. What is this mymath.jar and what does it contain? It's actually a zip file, but let me do this. Let me copy this jar file. Find it first. There it is. And I'm going to place it in the my source folder. I'm going to put it over there. To give us an idea of what this is, I made a copy of it and I'm going to rename the extension to ZIP, which is a zip file. I double click on it, I get meta-inif, which gives me some information about this zip file. Basically, it's going to tell me that the version that it was compiled by is 1.8. And I can see it has the mymath subfolder, which has the addition.class, which is exactly what I'm looking for. So the jar command, the jar file is actually a zip file. And a zip file, if we had a WinZip tool or something similar, and we were to look at the files in it, we will see that there is a addition class, and along with the file, it has the folder structure in the zip file that it's in. And it will tell us, hey, this is the mymath folder associated with addition.class. So now Java has this information that, okay, we've got the mymath subfolder, and inside that is addition.class. If I had more classes to distribute, I could put all of those in a .jar file and then hand out the .jar file. Now this use my math, instead of using the subfolder in that other intro folder, the subfolder my math, I'm going to use this .jar file and it will find the addition.class and compile this and run. Again, I use the -cp command and I can specify the jar file and then put the name of my use my math. And it compiled it without any issues. Usually, if something gets compiled, we can run it. I use the same strategy with the Java command, take out the .java, do the -cp, and it's utilizing, oh, could not find or load main class, use my math. So let's see what's going on over here. What's going on over here is the same problem I told you about. We need to specify the current folder. Hopefully this should fix it. All right. So unless if I don't specify the dot here, it's not looking in the current folder for the use my math class. Okay. It's looking only, it looks at my math.jar, which is not a folder, but I need to explicitly state the dot to tell it to look in the current folder for the use my math class. This concludes part 1 of the introduction to Java. Again, the website for the code and the material is this one. Thanks, everyone.